Chapter 8 is about advanced SQL statements. So in this chapter, we are going to talk about multiple table queries, subqueries, procedures, and triggers. And procedure and triggers are programming capabilities of SQL language. Right? We are also going to talk about how to use SQL to create business applications using embedded SQL or dynamic SQL. You will see some examples of multiple table queries, subqueries, procedures, and triggers and embedded SQLs in this chapter. Even though Chapter 8 is entitled Advanced SQL, both Chapter 8 and Chapter 7 are actually just introduction to SQL. I mean, there are a lot of stuff in SQL. If you look at a SQL book, it's usually really, really thick. There are lots and lots of stuff in SQL. Here we have only touched the surface of SQL language. You will see a lot more examples and a lot more functionalities of SQL. So here I'm just giving you a general framework of what SQL is, some of the functionalities of SQL. These are some of the topics that will be covered in this chapter. We'll talk about multiple table SQL queries. That's a very important topic because in most cases, you will need to get data from multiple tables instead of just one table, as we saw in Chapter 7. We'll talk about different types of joins. Like when you need to get data from multiple tables, you will join these tables together in order to get the information. So there are a number of different types of joins you can use to join tables. Okay. And we'll talk about subqueries. There are two types of subqueries. One is called a non-correlated subquery. The other is called correlated subqueries. They each serves a different purpose. So we'll talk about these two different types of subqueries. We'll talk about triggers and the stored procedures. And here in this chapter, I'm just going to give you a very brief introduction to triggers and the stored procedures. Those are the programming capabilities of SQL. These two are very important tools used by database administrators or database developers to create database applications or manage a database. We'll also talk about some of the SQL 2000N standard and its extension of the SQL 92 standard, which is a widely accepted standard. And also we'll talk about the use of SQL in online transaction processing systems and the online analytical processing systems. So those are the topics that we are going to cover in this chapter. Let's first talk about multiple table joins. The power of relational database is realized when you work with multiple tables. Because in a relational database, we have many tables, and all of these tables have a relationship with each other. And the way we establish these relationships is through the primary keys and the foreign keys. There is an operation called a join in relational database. And the join is an operation that will cause two or more tables with common domain to be combined into a single table or view. So join basically means we are combining two tables together into one. That's also the reason why relational database often suffers from poor performance. Because you have to join tables to create larger tables, it usually causes a lot of overhead and requires a lot of computing power. So when you create a join, what will happen is you are creating a bigger table. So for example, if you have a table, order table, and you have another table, customer table. And if you need to get information or data from both the order table and the customer table, let's say you want to get a list of customers and their order numbers. You need to get the customer information from the customer table, and you need to get the order data from order table. In order to do that, you need to join these two tables together. So let's say if there are 15 customers in your customer table, and if there are 10 orders in the order table, when you perform the join operation, what will happen is you will end up with a table with 150 rows, which is 10 times 15. So that's a much bigger table than the original two tables. So that's why a relational database often suffer from performance issues because of these joining operations. However, joining operations is also one of the most important operations of relational database because it makes the relational database very flexible and allows business managers to query the database in an ad hoc manner, because you don't have to define how you're going to use the database beforehand. You can join tables in many different ways to answer different business questions. There are a number of different types of joins you will see. The basic type of join is something called equal join. And the equal join is a join in which the joining condition is based on equality between values in the common columns. And the common columns appear redundantly in the result table. And the common columns here are referring to the primary keys and the foreign keys. In the example here, the order table has a foreign key of customer ID, because between the customer table and the order table there is a one-to-many relationship, right? When you see a one-to-many relationship, the primary key of the one side becomes a foreign key of the many side. And the customer table has a primary key of customer ID. When we perform an equal join, what will happen is we are going to match the customer ID in the order table with the customer ID in the customer table. When there is a match, then it means this customer has placed an order. And also when you perform a join here, what will happen is the customer ID field in the order table and the customer ID field in the customer table will both appear in the result. Right? So you will have two columns, both of them are called customer ID, but they are from two different tables. So you have redundant result in the results of the query. Then there is something called a natural join. And the natural join is the same as equal join, except the duplicate columns is eliminated in the resulting table. What it means is, well, in the result, we do not show the customer ID twice. We only show the customer ID once in the result. Actually, a natural join is the most common type of join. When you use a database management system like Oracle or SQL Server, usually it does not use the equal join. It uses the natural join. It will only show the common column once instead of twice. So that's called a natural join. Okay, and then there is something called an outer join. An outer join is a join in which rows that do not have matching values in common columns are nonetheless included in the result table. So what does this mean? Well, it means, well, let's say if you have 15 customers and only 10 orders. So obviously some customers did not place any orders here. When you do an equal join or natural join, the tables are joined based on the equality between the customer ID field in the order table and the customer ID field in the customer table. So if there is not a match, then it's not going to show up in the result. So what will happen is you will end up with maybe 5 rows in the result when you do an equal join or natural join. And it will only show the customer who have placed the orders. That's the result of the equal join or the natural join. But in outer join, the rows that do not have matching values in common columns are nonetheless included in the result. So what will happen is, well, you will have a few rows with customers who have placed the order, and then you will also have a few rows with customer information, but without an order number here. So that's called the outer join. And there are what's called a left outer join and the right outer join. And left is really referring to the table that appears on the left side of your SQL statement, and the right is referring to the table that's on the right side of your SQL statement. If you want to show all the customers, no matter if they have purchased anything or ordered anything, then you probably will do a right join here, because we have the customer table on the right side of our SQL statement here. And then the last one is called the union join. Union join includes all columns from each table in the join and an instance for each row of each table. Say if you have 10 records for orders, and for each order you have 6 columns. So for the order table, it's a 10 by 6 table. And if you have 15 records for the customer, and each customer has 3 columns, okay, then for the customer table, it's a 15 by 3 table. So when you create a union join, what you will have is you will have a table that's 25 by 9, which is 10 plus 15 and 6 plus 3. So what you will have is you will have a row for each order or customer, right? And then obviously for some of the columns you may not have a value. So for example, this is a customer record. So you have 3 columns that are filled with value, and then you have 6 columns that have null values. And if this is an order record, then you have 3 columns that have null values, and then 6 columns with values. That's called a union join. You're basically putting all the values from both tables into a bigger table. 4 types of joins are probably better illustrated by the Venn diagrams in this slide. This is the equal join or the natural join. So the left circle here is the customer table, and the right circle here is the order table. And when you do an equal join, you are matching the primary keys with the foreign keys, and only the records where the primary keys match the foreign key will be included in the result. And then this picture shows the outer join. So this happens to be a left outer join, right? Because we are displaying all the records in the table on the left side, so it's called the left outer join. If we are displaying all the records on the right side, then it will be called a right outer join. So let's say this is the customer table on the left, and this is the order table on the right. What will happen is it's going to list all the customer records, no matter the customer has purchased or placed an order or not, and then will list only the matching orders. And then this is called the union join. These 2 tables together, and all the records are returned in the union join. Alright, let's look at some examples of these different types of joins. First, just to give you a context here, all the examples we are going to see in the next few slides are based on this scenario. We have 4 tables: the customer table, order table, product table, and the order line table. And the order line table is the associative entity between the product table and the order table here. Customer places order, order contains order line, and order line has product. So that's the scenario. Here are just the 2 tables. One is the customer table and the order table. Right? Those are the 2 tables we are going to use most in these examples. So as you can see here, in the order table we have 10 records, and in the customer table we have 15 records. So obviously some customers have not placed any orders. Let's take a look at a natural join example here. Okay. This is the natural join example, and the natural join, as I mentioned earlier, is the most commonly used form of join operation. So by default, most join operations you see in SQL are natural join. The question we are trying to answer here is, for each customer who placed an order, what is the customer's name and the order number? In order to get the customer's name and order number, we need to get the data from both the customer table and the order table. The statement looks like this: select customer table.customer ID. The customer ID is from the customer table, comma, customer underscore name, and comma, order underscore ID. Right? And order underscore ID here is from the order table. And the from, okay, in the from clause, we are going to join the tables. From customer underscore T, right, refers to customer table. Natural join order underscore T, which is the order table, right? And on customer table dot customer ID equal to order table dot customer ID. What we are doing here is we are matching the customer ID field in the customer table with the customer ID field in the order table. Right? If there is a match, then we are going to list that record in the result. So in this particular case, we are joining the table in the from clause. There are actually a number of different ways to write the join statement. The one you are seeing here is a join in the from clause. Well, there is another syntax you can use for join in this case. You can write select customer ID, customer name, order ID from customer table and the natural join order table. Instead of using the keyword on here, you can use the keyword using and followed by the field that we are going to use to match the primary keys and the foreign keys, which is customer ID. So that's another way to write the same SQL statement here. As you can see, the difference here is instead of using the keyword on, we are using the keyword using. And here we do not have an equation here. We just put in the name of the field that we are going to match. And this can only be used if you name the primary key and the foreign key the same. In this case, we call the primary key customer ID and we call the foreign key also customer ID. So that's why we can use this using syntax. And then there is also another syntax we can use, which is to join the tables in the where clause. Where clause is where we state the condition for join. If we try to join the tables in the where clause, what we can do is select customer ID, customer name, order ID from customer table, comma, order table. And where the customer table dot customer ID equal to order table dot customer ID. That's another acceptable syntax for join statement. So instead of joining in the from clause, we are doing the join in the where clause. So all of these three are acceptable syntax for join in this particular case. Okay, so what's the difference between joining the tables in the from clause and joining the tables in the where clause? Well, the difference sometimes is really the performance. So remember in chapter 7 we talked about the order of processing a SQL statement. The from clause is processed first and followed by the where clause. So if we join the tables in the from clause, we'll create a smaller table to begin with. Let's say you have 15 records in the customer table and 10 records in the order table. If we join these two tables in the from clause, so we are already eliminating a lot of the records that do not match. What if we are joining the tables in the where clause? What will happen is, well, we'll get these two tables in the from clause first, so you end up with a table with 150 rows, and then you look at the where clause and try to eliminate the ones that do not match. So performance-wise, seems like joining the tables using the from clause will perform better than joining the table using the where clause because you are dealing with a smaller intermediate table here. The difference in performance will only be visible if the tables are large enough. If you only have 10, 15 records, then you probably wouldn't see a difference. But if you have 2 million records in these tables, then you definitely see a performance difference. Let's take a look at an outer join example here. List the customer name, ID number, and the order number for all customers. Include customer information even for customers that do not have an order. In this case, we are going to select customer table, customer ID, customer name, order ID, and from customer table. And so we are going to use the keyword left outer join order table. Okay, so we are using the keyword left outer join, which means we are going to list all the records of the table on the left side of this statement here, which is the customer table. So it will list all the customers, no matter whether the customer has purchased or not. And on customer table, customer ID equal to order table, customer ID. We are still matching the primary keys with foreign keys. So the result you are going to get from this outer join statement is this. As you can see, here we have all the customers, and then we have all the order IDs. However, you will see that some customers do not have a matching order ID. And the reason is because the customer has not purchased from us before. So that's outer join. Right? We are listing everything. It doesn't matter if there is a matching record or not. So why is this useful? Well, sometimes you may be interested in finding out which customer has never purchased from you before. And maybe the question is, I want to figure out which customer has never purchased from us before, right? So that we can create some marketing campaigns targeting these customers. So if you use an outer join to get this result, how do you get a list of customers that have not purchased from you before? Well, you write another SQL statement, right? And in the where clause, you just say order ID equal to null. Those would be the customers that have never purchased from us before. So far, the examples we have seen only involve two tables. What if you need to join more than two tables? Here is an example of if you want to join more than two tables. Assemble all information necessary to create an invoice for order number 1006. In this case, you need information from multiple tables. You need information from the customer table, the customer who placed the order 1006. You also need information from the order table. And you also need information from the order line table as well as the product table. So this is the SQL statement to answer this question. We're going to select customer ID, name, address, city, state, postal code, order ID, order date, quantity, which is from the order line table, right? Product description, standard price, and also we are going to perform a calculation here. Quantity times unit price to get the subtotal for each item. And the product description, standard price are both from the product table. From customer table, order line table, and the product table, where we need to join these tables. So we need to customer ID of the customer table equal to customer ID in the order table, and the order ID in the order table equal to the order ID in the order line table, and product ID in the order line table equal to the product ID in the product table. And we need to add one more condition here, which is the order number equal to 1006. As you can see, in the where clause here, we have the condition order number needs to be equal to 1006. And also we need to have 3 join statements in order to join 4 tables. So if you want to join 4 tables, you need 3 join statements in the where clause. So what if you need to join 8 tables? Then how many join statements do you need? 7, right? It's always n minus 1. The result for this query will look like this. You get a list of customer ID, name, address, and the order date, order quantity, product, standard price, and then the subtotal for each line of order. Again, same as 2 table joins, there are multiple syntax for multiple table joins. In this case, we are joining 4 tables. Well, what are some of the alternative syntax for joining more than 2 tables? There are 2 alternative syntax. There is something called the nested join syntax. And that's used for when you're trying to join 3 tables. What you will do is you will try to join 2 tables first, right? And then you will join the 3rd table with the result of the first join. So that's called the nested join syntax. Let me show you an example here. Say we want to select the order ID and the quantity and also the product ID. Well, these 3 fields are from 3 different tables, right? Order ID is from the order table, quantity is from the order line table, and the product ID is from the product table, right? So we need to join 3 tables together. What we can do is we can do from, okay, order table join, or natural join if you want, and then parentheses here, order line table join product table, okay, using product ID. On, we can do either on or using order ID. As you can see here, within the parentheses here, we have what's called a nested join here. The statement within the parentheses joins the order line table and the product table using the common field, the product ID. This is going to give you an intermediate table with the order line table and the product table. So then we are joining the order table with this intermediate table using the order ID as the common field. So now we are joining three tables here. So that's another syntax. Another syntax is the non-nested join syntax. So we are just going to join table one after another. Okay. So we are going to do select order ID, quantity, product ID from order table join. But the table that the order table is going to join is the order line table using order ID, and followed by join, another join statement, the product table using product ID. So what we are doing here is simply joining the order table with the order line table first, right? And then joining the intermediate table with the product table. That's all. So that's another syntax you can use for joining multiple tables. Like if you have more than 3 tables, well, you can keep on doing the join and the join. Right? Based on our discussion here, and I just want to kind of summarize the thinking process you go through in create these select statements for multiple tables. The thinking process you go through in creating these select statements is that, well, first you want to understand the table structures. You probably want to start with the ER diagram actually, so that you understand the relationships between these tables. And then the next step is to identify the fields that you are going to display in the result. So why do you want to identify the fields that you're going to display in the result? Well, because that's what's going to go into the select class. And then the third step is to identify the tables. Sometimes just one table, but sometimes tables, where you can get these fields. So for example, if the order ID is from the order table, then you need to put from order, right? If the customer ID is from the customer table, then you also need to put customer table here in the from clause. To identify the tables is so that you can create the from clause. And then the fourth step is to see if there is any conditions. Okay? If there is any conditions, like for example, in one of the queries that we looked at, there is a condition that we are creating an invoice for order number 1006. Right? So that's a condition. Identify the condition, you can put the condition in the where clause. So where the order number equal to 1006. And then the fifth step here is to see if there is any grouping. Are you going to group the results by any grouping values? And so if there is, let's say if we want to group everything by the city, right? So then you need to put this in the group by class, right? Group by city or state or whatever. And then the sixth step is to see if there is any conditions for the group. Okay. So conditions for the groups. Okay. If there is, then you're going to put that in the having clause, right? Because having is really the where clause for the group. And then once that's done, the seventh step is to join tables. Let's say if you are trying to join 4 tables in the from clause, if there are 4 tables listed in the from clause, then what you need to have is 3 joining statements. If you have 8 tables you need to join, then there are 7 joining statements. And then the last step here is to see if you need to list the result in any particular order, because that's going to determine what to put in the order by clause. That's basically it. These are the 8 steps you go through in creating the select statement to query the database. Now, if you follow these 8 steps, it's a pretty easy process actually.